Hello everyone, myself Akshita from Sri Venkateshwara College of Engineering. Today I am here to explain the topic about non-deterministic finite automata. Let's move into contents. Introduction, definition, graphical representation of NDFA, example of NDFA, applications of NDFA and conclusion. Let's move in. Introduction. NFA stands for Non-Deterministic Finite Automata. It is easy to construct an NFA then DFA for a given regular language. The finite automata are called NFA when there exist many paths for specific input from the current state to the next state. Even NFA is not DFA, but each NFA can be translated into DFA. NFA is defined in the same way as DFA, but with the following two exceptions. It contains multiple next states and it contains epsilon transition. In the following image, we can see that from state Q0 for input A, there are two next states Q1 and Q2. Similarly, from Q0 for input B, the next states are Q0 and Q1. Thus, it is not fixed or determined that with a particular input where to go next. Hence, this FA is called non-deterministic finite automata. Definition. A NFA is a collection of 5 states same as DFA as we described in the definition. Q. Finite set of states. Sigma. Finite set of the input symbol. Q0. Initial state. F. Final state. Transition function. Transition function can be defined as transition function equal to Q into sigma gives 2Q. Graphical representation of an NFA, that is non-deterministic finite automata. An NFA can be represented by digraphs called state diagram. The state is represented by vertices. The arc labeled with an input character show the transitions. The initial state is marked with an arrow. The final state is denoted by the double circle. Let's move into example of non-deterministic finite automata. Example, design a NFA with sigma equal to 0, 1 accepts all string with 0, 1. As you can see the solution, there are three states Q0, Q1, Q2. From Q0 to Q1 0 and from Q1 to Q2 1. And remaining, if we get 0 once, it will be on Q2. So finite set of states Q is equals to Q0, Q1, Q2 and sigma equal to 0, 1. Start state is Q0 and final state is Q2. Transition table. There are three states, present state, next state for input 0 and next state of input 1. In present state Q0, next state for input 0 Q1, next state of input 1 is epsilon. And in present state, next we have Q1, next state for input 0 is epsilon, next state of input 1 is Q2. And at last, present state we have Q2. In next state for input 0 we have Q2 and next state of input 1 is Q2. As you can see in the above diagram, we can see that when the current state is Q0 on input 0, the next state will be Q1 and on 1 input, the next state will be epsilon. When the current state is Q1 on input 0, the next state will be epsilon and on 1 input, the next state will be Q2. When the current state is Q2 on 0 input, the next state is Q2 and on 1 input, the next state will be Q2. Next, application of NFA. NFA are mathematical models that are used to represent and analyze systems that can be described as a sequence of states such as computer programs, communication protocols, and natural language processing. In the text processing, regular expressions are a powerful tool for processing text, and they can be represented using finite state automata. Text editors, search engines, and span filters all use regular expressions and finite state automata to search for and manipulate text. Language processing. Natural language processing involves analyzing and processing human language, which can be modeled as a sequence of states. Finite state automata are used in some language processing tasks such as morphological analysis, which involves identifying the grammatical structure of words. Next application is protocol analysis. Communication protocols such as those used in networking and the internet can be modeled using finite state automata. Analysis of these models can be used to identify potential security vulnerabilities or to optimize network performance. Next application is hardware design. Finite state automata can be used to model digital circuits and computer hardware. They can be used to optimize circuit design, improve circuit performance, and identify potential design flaws. Next, compiler design. Compilers are programs that translate code written in one language into another language, typically mission code. Finite state automata are used in the lexical analysis stage of the compiler, which involves identifying the basic units of the language, such as keywords, operators, and identifiers. Next, moving to conclusion. In conclusion, NFA are fundamental concepts in automata theory. They are equivalent in terms of the languages. They recognize allowing conversion between the models. While DFA operate deterministically, NFA introduce non-determinism. Understanding the equivalence and differences between DFA and NFA is essential for designing efficient automata-based systems. Thank you.